This is not my first time to talk, but this is my first time to Australia and talk about the Rails performance tips. So I hope you will enjoy it. So someday, when you have a website, you launch it, you may feel it may be slow on the browser, then you will wonder where you can start to optimize it. So Steve Souders, who wrote book High Performance Website, mentioned that 80 to 90% of the end user response time is spent on the front end. So it's better to optimize your front end performance first. And 3 years ago, still in Ruby Conference Australia, Keith and Mariel gave an awesome presentation talking about front-end performance, optimize the Rails front-end performance. So I won't repeat everything they already said, so I just will list them quickly. So I categorize their tips. So the first one is send as less requests as possible. So when user visits a website, the browser will send a request to get HTML, that it will send multiple requests to get the CSS and the JavaScript files. But you know that sending HTTP requests is expensive. So by default, Rails will concatenate CSS and JavaScript file into one. So after HTML is fetched, it just sends one request for CSS and one request for JavaScript files. And it's the same idea to use CSS sprites. If you have many small images or icons, you can use CSS sprites to concatenate these images into one to reduce HTTP requests. And the second is return as small payloads as possible. By default, Rails will minify or compress your CSS and JS files, and it will use gzip to compress them further. So in general, your CSS and JS file will be compressed, will be reduced at least by 80 to 90%. Compressed images, so there are already some tools that can reduce your images to a smaller size without losing any information. Cookie-less domains. If you check your request for CSS and JavaScript, you probably will see the cookies in your request body, but they are useless. So you can use another domain for your CSS and JavaScript to avoid sending this useless cookie in HTTP requests, which also speed up your access loading. Third is to use as fast resources as possible. Use CDN. CDN nodes spread throughout the country or all over the world are geographically closer to your users and ensure a faster response because of the reduced latency. There are other tips that you can put JavaScript at the bottom of your HTML body to render the page faster. Okay, besides front-end performance tips, I'd like to talk more about the back-end performance tips. You may think that back-end performance tips, it's only back-end performance rendering time, it only takes 10 to 20%. Is that mean that back-end performance less important? So it's not true, because the rule that the front-end performance takes 80 to 90% of the end user response time is based on the normal load conditions. So during a traffic spike, the back-end response time can play much bigger role. So okay, when you see a back-end performance issue, how do you fix it? What will you do? So the first and the most important thing is don't guess, don't guess, don't guess. So don't just take a look at the code and just say, okay, I guess the performance issue is blah, blah, blah. It's not a good habit. You should find out the real bottleneck on production. So to find out the bottleneck on production, you must have a performance monitoring tool. And it will give you a better idea of your application performance. So I prefer New Relic, but you do have other options like Skylight. So on New Relic, you can see the web transactions average response time on your app server or on browser. And you can see different time spent on middleware, on Ruby, on database, on Memcached, and essentially. New Relic will give you the list of transactions by order by the response time, so you can try and improve the slowest transactions. And for each transaction, it will break down to segments, display the name, the time percentage, the average cost, the average time for each segment. It helps you to find out performance bottleneck easily. Okay, after you find out the performance bottleneck, then you need to reproduce it locally. You should simulate the environment, install the dependencies like the Postgres, the Memcached, Redis, etc. You also need to simulate the data on production, because which is the key to reproduce the production user load. And even running locally, you still need to monitor the performance. So I will use the New Relic developer mode, and you can choose other tools like Rec Mini Profiler. If it gives you the same or very similar performance report, then you do successfully reproduce the performance issue locally. So this is the New Relic developer mode, and it will track the response time for each request you send locally. And this is the performance summary for each request. And this is the detail page. It will display the time for different parts, like the rendering the view or the SQL queries. And this is the SQL page. It will list all the SQLs generated by one request. Okay, sometimes it's hard to prepare the data locally, like too much data on production, or the performance issue only happens to one specific user. So it's a tip that you can create an app instance on production by running on development environment with New Relic development mode, but connection to a database, production database and production Memcached. Then you can have the same user load and the data as production environment, and then you can just send a specific request to that development instance. You can get a detailed performance report for the specific request and the specific user. Then you can fix the performance issue locally. After changing the code to fix the performance issue, we need to make sure it does speed up, so we should do benchmark. There's a gem Rails perf test that you can write some test code to do the performance test. Here, we just send a request to a home page, and after we run rake test benchmark, it will show you the total process time, the memory usage, the objects are located. And you should run the benchmark test before and after you fix the performance issue, then compare the results to see if you do fix the issue. I also try use AB or Siege to send concurrent requests to local instance and monitor on New Relic and compare the average response before and after. Okay, let me give you a summary. First, you should have monitored the performance on production, find out the bottlenecks, reproduce locally, fix it, do the benchmark to make sure you do speed up, deploy on production, then keep monitoring it. Okay, now I will show you some backend performance tips I usually use, and I also categorize them. So the first one is the same, to send as less request as possible. First is N+1 query. Here I load 10 comments. For each comment, I will display the username with the comment body. So it will send a SQL request to get the 10 comments. For each comment, it will send additional 1 SQL to fetch the user data from database. So it's a typical N+1 query. So on New Relic, you will see the user find operation. It sends 10 times and takes 3.88 milliseconds. And the total response time, that means the observer received the request and send the response. It takes 12.3 milliseconds. Okay, to fix the N+1 query here, I just add the Rails includes method to eager load the user data. Now it just sends 1 SQL to fetch all the users for the 10 posts. Now you can see on New Relic the user find is only be called once, and the time spent is 0.621 milliseconds. So compare the results before and after. The total response time is reduced from 12.3 milliseconds to 6.81 milliseconds. It's 45% improved. And just for the SQL query, it's reduced from 3.88 milliseconds to 0.621 milliseconds. It's 64% improved. Okay, I created a gem called Bullet, which can help you to find out N+1 query during development time. Second, account cache. For example, here I load 10 posts. Each post I will display the comment size. And the same, it loads 10 posts, and for each post it will send additional count SQL query to calculate the size of the comment. And then on New Relic, you will see the SQL select is called 10 times and takes 5.86 milliseconds. And to fix it, we just add a counter cache column to the post table, and it will pre-calculate the comment count for each post when creating and destroying a comment. Now it just sends the query to fetch the 10 posts because the counters count already in this table. Now on New Relic, you just see the post find query. It just 0.511 milliseconds. So the total average response time is reduced from 12.3 milliseconds to 7.04 milliseconds. It's 43% improved. And for the SQL query, it's reduced from 6.434 milliseconds to 0.511 milliseconds. It's 92% improved. You can use Bullet as well to get some warning when you develop your application. It will tell you what column you should add just where you should add your counter cache column. It's a bonus that there's a gem called the counter culture. It gives some more powerful to counter cache, like updating your counter cache when value change, not just creating or updating, or creating or destroying. Use group. Sometimes the business can be more complicated. Like I want to calculate the average rating for approved comments. And I display them one by one for the post. So it sends a SQL request to fetch 10 posts. For each post, it sends average SQL query to calculate the average comments rating for that the comments the approved are true. And in New Relic, you will see the SQL select. It calls 10 times and takes 6.42 milliseconds. I use a gem called eager group, which helps to define a group operation for clashing, and it works very similar to includes method. So it will eager load the aggregation data. So you will see it only send one SQL query to database. It will calculate the average comments rating for all the 10 posts and still these comments are already approved. So on UREC, you will see the SQL select is only be called once, and the response time is just the average time for that SQL query is just 1.55 milliseconds. So the total average response time is reduced from 17.4 milliseconds to 7.48 milliseconds. It's 57% improved. And the SQL query is reduced from 6.62 milliseconds to 1.55 milliseconds. It's 99% improved. So we created the Eagle Group gem. It just to make writing group SQL in rows much easier. But feel free to write the row group SQL by yourself. So if you are using Postgres and you don't need the real-time aggregation result, so you can try the material view. It will pre-calculate the aggregation value in the database view. So it's much faster than use group to fetch the real-time aggregation. Besides multiple queries, multiple inserts also hurt your performance. Here we create 10 posts one by one. And you will see it will send 10 inserts to your database. And for each insert, it will send begin and commit for database transaction. So on UREC, you will see it sends 20 SQL others and 10 SQL inserts. It totally takes 19 milliseconds. And we can use active record import to do the multiple insertion. But be aware that it won't trigger validation and callback, so be careful. So you will see that it only sends one SQL to the database, and including all the 10 posting data. OK, so on UREC, you just see one SQL insert, and it takes just only 2.39 milliseconds. So the average response time is reduced from 35.4 milliseconds to 11.6 milliseconds. It's 67% improved. And for the insert SQL, it's reduced from 19.39 milliseconds to 2.39 milliseconds. It's 88% improved. So you can active record import is just a gem to do the multiple inserts for active record. It's the same idea that you should use update all to do the multiple updates, and you should use like destroy all and delete all to do the multiple deletes. OK, second is return as small payloads as possible. Here I load 10 posts, but I just display the title of the post. I query all the attributes for the post, and it takes 1.563 milliseconds to render the page, or to load all the post. Because I just display the title, so I can just query the title from database. Here I just use select the title. So the SQL is just to query the title from database. And the time spent for the post find is just 0.421 milliseconds. The total average response time just reduced from 4.86 milliseconds to 4.54 milliseconds. It's just 7% improved. Doesn't make much sense. But for the SQL time, it's reduced from 0.563 milliseconds to 0.421 milliseconds. It's still 25% improved. So most of the time, we don't need to do this. But if you have a large text in your database, you should give it a try. Third, you should use as fast resource as possible. Use cache. here I load 10 posts, and for each post I will query the user's name and the title. So it will send a SQL to query all the posts, and for each post it will query the user from database. On Nuret, the user find is called 10 times and takes 4.21 milliseconds. The index page is rendered in 3.9 milliseconds. So here I just added the memory cache to the page. For each post, it can be cached. So instead of load the user data from database, it just load the cache page from the memcached. Now you see the index page is rendered in 3.19 milliseconds, and the memcached gets called 10 times and it takes 2.78 milliseconds. So total average response time is reduced from 12.2 milliseconds to 9.97 milliseconds. It's 18% improved. And the database query to the memcached call is reduced from 8.11 milliseconds to 5.79 milliseconds. It's 29% improved. But be aware that multiple query from memcached still hurts your performance. So try to use rails.cache.readMult to query the multiple data from memcached at once. And the gem multi-fetch fragment makes rendering and caching collection of template partials easier and faster. And actually, it's already merged into Rails 5. And if you use that, this memcached get can be just reduced to 1 time. And there's also gem called second level cache. It can do the model layer caching, and it can also fetch multiple memcached data at once. And you can use Elasticsearch to provide powerful and fast search service. And you can use Redis to do the caching, to implement PubSub, Leadboard, and many other things. It's much faster than your transactional database. In case you don't use SSD on production yet, it's highly recommended that you should use that, and it will boost your performance immediately. And other tips, use database index. So here I query 10 posts ordered by created at. This is the SQL it generated. You will see on Nuret it takes 17.3 milliseconds. And after that, I add an index for the post created column. Then the time reduced to 0.595 milliseconds. So the total average response time is reduced from 21.5 milliseconds to 4.95 milliseconds. It's 99% improved. And the SQL query is reduced from 17.3 milliseconds to 0.595 milliseconds. It's 97% improved. You can try the LOL DBA gem. It helps you to find out the columns that probably should be indexed. Okay, optimized JSON rendering. So if you are building an API service, you need to return a JSON of the 10 posts here. So you will see the index action, it takes 3.92 milliseconds to render. To optimize the JSON rendering, I just added 2 gems. It's OJ and OJ mimic JSON. After that, you will see the index action. The time spent is 3.28 milliseconds. So the total average response time is reduced from 6.28 milliseconds to 9.76 milliseconds. It's just 8%, not much. But the index action is just the time reduced from 3.92 milliseconds to 3.28 milliseconds. It's 16% improved. But you don't do much, you just add the 2 gems, and then your API service just run much faster than before. Okay, OJ is the fastest JSON parsing and rendering gem right now, so you can get a try. Memory optimized. In the past few years, people always complain that Ruby and the Rails application consume too many memory, and it causes frequent garbage collections and slow down your applications. So you see some developers started to reduce objects all located in Rails. Like this pull request, it shaves off 1,114 string objects on every request in his application. And this pull request, it shaves off 34,299 objects on every request in his application. It's a huge improvement. So you must know that finding in batch, that it's just a technique to reduce the memory allocated. So instead of loading all the person from database and allocating the Ruby objects for the person at once, it's just query the person from database in batch, like query 1,000 persons from database and allocate Ruby objects for these 1,000 persons, do some operations, then release the Ruby objects, and then allocate objects for another 1,000 persons. Okay, so finding batch, it violates the rule we mentioned before. We should send as less requests as possible. Finding batch is send multiple SQL requests, but it reduces the memory usages and just reduce the garbage collections. So it can also speed up a lot. So no tips is always true. You should monitor your performance on production, and for different use cases, you should try different solutions. Okay, let's do a review. So if you see your website is slow, first you should try the front-end performance tuning, and be in mind that the back-end performance tuning is important. And when you do the performance tuning, so try to send as less requests as possible, and return as small payloads as possible, and use as fast as resources as possible. And there are other tips. And on production, you should monitor the performance for your application servers and find out the true bottleneck, try reproduce it locally and fix the performance. Do the benchmark to make sure you do fix the performance issue, and then deploy it on production, and keep monitoring your performance on production. The demo code I mentioned before is already on GitHub. You can check out, run it locally, and check out the performance on New Relic. And thank you.